Baudouin. I'm the president of Maid Lab Technologies. This video relates to the Maid Device Configurator software for the Volucalc Hybrid CS. The video explains in detail how to configure a Volucalc Hybrid CS designed for the analysis of pumping station using constant speed pumps. This video is also useful for users of the Volucalc Hybrid VS, since the VS is designed for both variable speed pumps and constant speed pumps. The Configurator software is on the USB key supplied with the device. The Configurator software can also be downloaded from its webpage on the Maid Labs website, www.maidlabs.com. Once on the website, go to the software menu, then to Configurator software, then press the download the Maid Lab Configurator software on the bottom of the screen. All that remains is to install it. So let's start the application. By clicking on the configurator icon on the desktop, or by clicking on SoftMaid, then on the configurator icon. This first page allows you to create a new file, which will create a new configuration file. You can open an existing file, mainly for the purpose of editing it or to understand why data are a certain way. Creating from existing file makes an editable copy of an existing configuration. This is especially useful when many stations are relatively similar, or when there are a lot of custom alarms that needs to be configured in multiple stations. Download configuration from Maid Maps allows you to download and edit a file from the SCADA server Maid Maps and edit it. You'll need to enter Maid Maps username and password, and if you don't want to enter your password each time you use this function, check the box Remember Password. If your login is successful, then the list of available stations will be displayed. The options are different if the configurator was open from Windows or within SoftMaid, because in SoftMaid the options also cover the SoftMaid software. In this video, description of the options is for an application open from Windows. The General tab allows you to choose a language. The Maid Configurator tab has elements that will alter available choices in different dialog of the software. Nobody should change the configurator's operating parameters without first contacting Maid Labs technical support. So this tab will not be explained. The Units tab is also directly accessible in all of the configurator screen, where change of units could be practical. Units can be changed on the fly when configuring a sensor using a different unit. It also changes the unit in report, but not those in Maid Maps, chart, and event reports. Whether you are in the United States, Liberia, Myanmar, or anywhere else in the world, the units that you are likely to use are different. Depending on your region, click on one of the predefined setup, which are International and United States for the countries I named. It is possible to choose each unit regardless of the selected predefined setup. Press OK when done. So let's create a new configuration file. Since the instrument for which we'll be making a file is a Volucalc Hybrid CS, you must enter a valid serial number here. If you just want to learn how to use the configurator software, you can enter a number which is 100 or less and it will work. The general information screen is related to its name, how it's powered, and how it communicates when it does. The device name is the name that will be in the instruments report and that will appear in the file name when they are downloaded. AC adapter means there is no battery backup that could be used to power the device. AC with battery backup means that there is a rechargeable battery connected to the battery connector, and that power is usually drawn from an AC connection. And in the absence of AC power, then the power comes from the battery. The instrument will keep its battery charge. External battery means that the main power comes from a rechargeable batteries unless it is indicated that it is a non-rechargeable lithium battery. In this case, the instrument won't try to charge a battery, which could be dangerous. About Ethernet communication. None means the device will not communicate. To recover the data, someone needs to go on site to copy the data file on a USB stick, which is always possible even for devices connected to the internet. Standard is for wired internet communication. In this case, communication is always active. The default communication interval is 5 minutes for maps data and 1 day for reports. Cellular modem is when communication is done using a cellular modem. In this case, the modem power goes through a relay in the instrument. This allows the modem to be powered only when needed. If you send a configuration update via Maid Maps to an instrument communicating my cellular modem, and in which the Ethernet communication is no longer cellular modem, then it will no longer be possible to communicate with the instrument or to receive alarms because the modem simply won't be powered anymore. Someone will need to go on site to change the settings back to what it was. So always be careful if you're using a cellular modem. Make sure that in your configuration, cellular modem is checked. Press Next. In the Display Option dialog, you can specify the language to use on the device's display and reports. You need to specify the time zone according to your region. You can adjust the display's brightness, but there are some things that are more convenient to change directly on the device. If you want to protect the instrument's configuration with a password, you will need to provide a password consisting of 5 digits between 1 and 4 inclusively, because on the device there's only 4 buttons. When that is done, press Next. The lift station screen is for selecting the number of pumps, the flow algorithm, and power settings to calculate the pump's efficiency. Select the number of pumps. Pumps with soft starts and soft stops are considered to be constant speed pumps. Maid Labs Technicians Department can adjust the acceleration and deceleration period for these type of pumps. A variable speed pump operating at a fixed RPM is considered a constant speed pumps. Measurement options relates to the optional wattmeter module, which is used to record more accurate electrical measurements. This module reads current and voltage on all 3 phases powering the station or powering each pump depending on what is checked, per pump or global. The standalone Configurator software doesn't offer the global option, but curiously, it is available when the configurator is started from within SoftMaid software. If you need the global option, but don't have SoftMaid, ask Maid Labs Technician Support to do it for you. In the flow algorithm section, none means the instrument will record everything but won't calculate or record flow. This can be practical when using the instrument as a data logger. After all, the Volucalc has 6 highly configurable analog inputs and an extremely large memory capacity. External flow measured means the Volucalc will not perform any flow calculation, but will use measurement from an external flow meter instead, for example, a magnetic flow meter, and the result generated by Volucalc will display this measurement. Fixed pump capacities means capacities are entered in the software and the resulting calculated flow rate is equal to the pump flow, whether it is good or bad. Pump curves is for variable speed pumps. Their curves are used instead of fixed capacities. But to use this function, the pressure head is required, so it is necessary to connect the level and the outlet pressure to the Volucalc. The outlet pressure is not required on a gravity line. Volumetric is the most used flow calculation function in the world for wastewater pump station. With Volucalc, it is used when there is no analog level sensor, so pumps are mostly controlled by float switches. For most lift stations, Volucalc calculates a flow rate with an error of less than 2%. Volumetric with level sensor, the ability to calculate flow in real time, which is actually every 30 seconds, or faster depending on the magnitude of the level variation. This function allows the operating level of the pumps to be adjusted according to the flow rate entering the station. This can lead to a reduction of more than 25% of the runtime of the pumps, which proportionally reduce the electrical bill, the maintenance, and the wear cost. The electricity section relates to the energy consumptions of the pumps. To calculate the number of kilowatts consumed by a pump, multiply the voltage by the power factor by the current used by the pump. Since Volucalc normally only uses a single current sensor connected to a single phase, then it is necessary to indicate the number of phases feeding the pumps. Volucalc will multiply the measured current by the number of phases. The average voltage powering the station is entered, and you indicate how it is measured. The power factor is normally indicated on the electrical service provider's invoices. The closer this factor is to 1, the more efficient is the electricity used. To see the cost of electricity consumed in the reports, indicate its cost per kilowatts. Greenhouse gas can be calculated for inefficient pump. Based on how the electricity is generated, this number can greatly change. The flow algorithm options is to be able to specify the pump combination capacities. Sometimes it is easy to calculate the flow of a single pump, but difficult, if not impossible, to calculate the flow of a combination of pumps. For example, when the water inlet is just above the starting level of a single pump, and you are not sure whether you can correctly measure the volume, or when it's so rare that multiple pumps are running simultaneously, you might want to manually enter the capacity of the combinations. Clicking on Let me specify pump combinations capacities will add an additional dialog allowing you to enter these problematic capacities. Press Next. Inputs and outputs. This is where you specify what is connected to the device. The order and color code are the same as what you see on the Volucalc. All output relays on this instrument have a capacity of 1 amp at 36 volts. If you want to use a higher voltage, then you should add a low voltage relay to do that. It can be used for alarm, to power the modem, to generate pulses proportional to the incoming or outgoing volume, or resulting from the open channel flow calculation. The expansion connection is not used. Pump 1 to 4 are used to connect the pump's current sensors or to get the variable speed pump's RPM when used with the Volucalc VS. The choices represent those offered by Maid Labs, but it is not mandatory to use those from Maid Lab. Inputs that are not used for current can be used to record something else and can be configured as 4 to 20 milliamp, 0 to 5 volt, 0 to 10 volt, and 0 to 24 volt. It can be used to record anything you want. And setting them up is very easy. We'll see about that later on. The 12 VDC out is directly connected to the power supply of the device. If the device is powered by a 24 volt source, then the output will be providing 23.3 volt, since part of the voltage is used by a diode and protection fuse. During a power failure, if a battery is connected to the Volucalc and it's 12 volt, then that 12 VDC output will supply the battery voltage. So that output is usually used for powering a cellular modem and a level sensor. We recommend functional accessories with a wide voltage range going from at least 9 volt to, let's say, 36 volt. This loop output proportional to inflow and outflow, and it can be proportional to a generic flow, which is the open channel flow formulas that the Volucalc has. And regardless of the selection, it is very easy to adjust the settings. So for example, if I would like 20 milliamp to be equal to 100 GPM, I will simply enter 100 GPM here, and that's it. It's done. It's that simple. This output is not functional on battery power. Then you have relay 1 and relay 2. In the previous screen, we specified that we were using a cellular modem to communicate. So a relay is pre-configured to activate the modem when communication is needed. And by default, the other relay is used for alarms. The level and pressure input can be configured and used like any other analog input, but current sensors cannot be connected to them. Since their main use are level and pressure measurement, this is what we have written on their labels. If at the start of the configuration you have selected volumetric with level, then a level sensor will be selected by default. To use the one already installed in the station, click on the arrow, select custom level, then set it to whatever you have at the station. If you're using a 0 to 5 volt instead, just go and select 0 to 5 volt instead of 4 to 20. That's all there is to do. The rain input is a digital input. Its primary use is to record clicks from a rain gauge, but it can be used to record pulses of incoming volume or outgoing volume, or from an open channel flow meter, or whatever other type of pulses to record an intrusion or the state of a float switch, or whatever that is digital. The battery end connection is for the main or battery backup power, so it keeps the device running even during a power failure. This can be useful if you want to be warned that there is a power failure and that the level has just becoming critical. The device manages the battery charging functions. The 12 VDC in is actually a 12 to 24 volt input. Press next. If you have selected volumetric with level sensor in the lift station screen, it is possible to indicate what is considered to be level 0, which most of the time is the bottom of the well. You simply need to enter the distance from the sensor to the water, then the depth of the water. The total of these two is used to determine the distance between the sensor and the bottom of the well. It is usually easier and more precise to adjust this on-site through the device's menu. Check the overflow level if there is an overflow pipe. Then the Manning equation can be used to determine the volume and flow of water that escaped through it. In that case, specify at what height is the bottom of the overflow pipe. If a backup battery is used to power the level sensor and you want to increase the reading frequency as you approach the overflow level, you can indicate it here. It is only when there's a power failure. Press next. The open channel flow window will appear if a level sensor is used and the overflow level box has been checked in the previous screen. If you want to get more information about the different algorithms that are integrated in the Volucalc for open channel flow, I suggest that you look at the flow made video. In this case, we'll be using the Manning equation full pipe. So just need to enter the information here. Let's say it's a 8-inch diameter. So I will go change the units, go to inches, press OK. 8 inches, press next. The pump capacities dialog only appears if, at the beginning, when specifying the calculation algorithm to use, the Let me specify pump combination capacities option was checked. If no value is entered in the table, then Volucalc attempts to calculate the capacity of the pumps and the combination of pumps. If a value is entered in a table for an individual pump, but not for the combination, and the box allows the device to update capacity is not checked, then the value assigned to the combinations will be based on the percentage entered for the default combination ratios. This means that when two pumps will be running together, the combination of the two pumps will be 75% of the total of the pumps in operation. And you can do that for 3 pumps and 4 pumps. And you can change these settings. If a value is entered in the table, but the allows the device to update capacities box is checked, then the entered value, the 100 we see here, will be used as the starting point instead of 0. It is as if the history to date arrives at this value. In this case, each time a new capacity is calculated, it will affect the historical capacity, which is used to calculate the inflow in real time when one or more pumps are in operation. Press next. In the well dimension dialog, we'll talk about the most popular shapes, which are rectangular, and cylindrical. You simply need to enter the area of the well. If the area change at different levels, then you might want to consider something different. You can even enter formulas for conic shape if you need to. The general dimension is not important. You have to remember that a volumetric flow meter needs an accurate volume to calculate flow. So if the inlet is semi-submerged and you're not able to calculate in any way the volume of that semi-submerged inlet, then you won't have accurate flow from a volumetric algorithm. You might want to use another type of algorithm for that. Press next. The operating mode dialog appears only if you have selected volumetric in the algorithm, not volumetric with level sensor. When there is no level sensor, this dialog is used to indicate the starting and stopping levels of the pumps, so the volumes between the operating levels of these pumps can be calculated. The most used operating mode is the one offered by default, that is, one start level per pump and a common stop level. In this case, each time a higher level is reached, one more pump starts, and they all stop at one common level. The other popular predefined operating modes are distinct start and stop level per pump, and one start level per pump and pump stop one level below. In this case, each time a higher level is reached, one more pump starts, and each time a lower level is reached, one pump stops. It is possible to customize the operating description for stations that do not fall into one of these three operating modes, but it won't be explained in this video, and it's used the customized section here. The measurement method. Distance from the bottom of the well is a popular method since it is the one used in the station specifications. Most level sensors display readings from the bottom. If you use the displayed value of a level sensor, please cross-check the accuracy of the level sensor, because almost every time someone tells us Volucalc is not accurate, is because their level sensor is the problem. Distance from the top of the well is the easiest to use for double-checking the measurement used or creating the first good measurement. A floating weight is attached to a measuring tape, and measurements are taken while the pumps are operating. Even if a level sensor is used, a measuring tape should be used to ensure that the sensor is giving an accurate measurement, since all Volucalc calculation results will be proportional to the accuracy of the measurement entered. So distance from the top means that the lowest level, the stop level, will be the longest, and the lag level will be the shortest. Distance between levels is another method of measurement. A floating weight, like a piece of wood, is attached to a rope. Each time a start or stop level is reached, a marker is used to indicate on the rope the height reached relative to a common reference, such as the well cover. Then you measure the distance between the marks on the string. Volume from bottom, volume from top, and volume between levels compensate for elements affecting the area of the well, which could vary depending on the level reached. For example, if there is a wall or a pump or other physical element that could influence the volume to be used in the flow calculation, then entering the right volume could be more accurate. If distance from top is used, and this is how I do a calibration on site, then the lowest level where all the pumps stop will be the farthest from the top of the well. And the more pumps become in operation, the shorter should be the measurement. So let's suppose that all the pumps stop at 15 feet from the top. Then the lead pump starts at 12 feet. Then the lag pump starts at 11.5 feet. This is the easiest way to configure a Volucalc in a lift station without any level sensor. Press next. The external battery dialog appears only if AC power with battery backup or external battery was selected in the general information screen. This dialog relates to analog input reading when operating on batteries. This is used only if a power backup battery is connected to the Volucalc to power, let's say, a level sensor or something like that during a power failure. In this case, The default values are set to read the level every 5 minutes when the level is below the fast reading level, and 1 minute when at or above the fast reading level. The fast reading level was previously set in the level setup dialog if volumetric with level sensor was selected at the beginning of the configuration. Press Next. Alarms will appear in the list of suspicious events at the end of the monthly report. Understanding how they work helps you avoid being swamped with insignificant events and be contacted when it's important. Volucalc offers different predefined alarms, and the user can add more if desired. User-defined alarms are black, while predefined alarms are gray. For predefined alarms, check or not those of interest. These are the preset alarms. Low external battery voltage is there only if AC power with battery backup or external battery was selected in the general information screen. Battery voltage gets too low, it will generate an alarm. Abnormal cycle state occurs when the Volucalc is set to volumetric, not with a level sensor. In this case, it's the pump operation sequence that tells the Volucalc when a level is reached. If unexpected sequence occur, then Volucalc will not be able to correctly determine the level and will indicate it with this alarm. Everything will return to normal when a known level is reached, such as when all pump stops. Abnormal pump sequence occurs when the pumps are expected to alternate, but there's a change in the alternation. For example, let's say we have pump 1, 2, 1, 2, then pump 2 again, before continuing as before between pump 1 and 2. If no one was there at the station to modify the alternation of the pumps, then this is the beginning of an intermittent problem which could generate to the point where one pump would no longer start. 1/3 of pump station has intermittent electrical problems. AC power loss indicate that there was a power failure or that the Volucalc was disconnected. Device restarts may occur when Volucalc is no longer able to communicate or calculate. In these cases, Volucalc restarts itself to put an end to the anomaly that may have caused this state. Ethernet communication problem is used when you want to test the communication, but with delay. This can be useful if a solar antenna is in the panel and you want to confirm that communication is good while the panel is closed. It is like performing an automatic communication test, but with a delay. Inflow out of normal range is when the inlet flow is much lower or higher than normal. The variation required is based on the standard variation of the samples. By default, the variation of more than 5 times the standard deviation is abnormal. This parameter can be modified by Maid Labs technician. Level drop without pumps can occur when there's a siphon effect, but this is extremely rare. A more common reason for this alarm is that the level sensor begins to fail. The level analysis in self-made should be performed first to understand the true nature of the problem. If the pumps are equipped with soft stops and their deceleration time has not been programmed correctly or programmed at all, then it is possible that the pumps is still in operation when the current threshold considers it as a stop. In this case, this alarm would appear at each cycle. Maid Labs technicians can modify your configuration free of charge, compensate for soft starts and soft stops. The user does not have access to the window allowing this modification. Long cycle can occur when the shutoff flow is faulty and when the cycle drags on, or the incoming water flow is so close to the outflow for a very long period of time, or any other reason that may abnormally stretch a pumping cycle. Operation level change occurs when the start or stop level varies enough to be considered change. This can happen when changing the level sensor or when the level sensor starts to have problems. Outflow out of normal range is when the calculated outflow is significantly outside the normal calculated outflow rate. The variation required is based on the standard variation of the samples. By default, a variation of more than 1.5 times the standard deviation is abnormal. This parameter can be modified by Maid Labs technicians. Pump capacity change can have two reasons. Either the pump is partially or completely blocked, or the measurement used to calculate its capacity has become false, which affects the pump capacity calculation. If the capacity variation affects all pumps equally, you might think that the problem is not the pump, but the level switch, which do not start or stop the pumps at the same level as before. Short cycle can occur when the relay that keeps the pump in operation begins to fail, or other reason that would create unusually short pump on or pump off time. Steady level means there is no more water entering the station. If it's not voluntary, it could mean that there is some very serious problem somewhere else. To add an alarm. Suppose I would like to create an alarm when the pump's current exceeds 10 amps for more than 5 seconds. In the alarm type box, the choices are high value or present, low value or absent, and value in abnormal range. There is no value outside of an abnormal range because it can be easily created using value too low and too high. So we'll select high value since we want to create a high current alarm. Then the measure that will be affected is selected. The choices are related to what is configured in the input and output dialog. Here are the most common choices. AC power, it's the same alarm as the one that is already preset. External voltage allows you to be warned when the battery voltage becomes too low. Inflow, which could be too high or too low. Miscellaneous digital can be used to create an intrusion alarm or that a critical level has been reached. Outflow for each of the pumps. A change in pump capacity is one of the predefined alarms, but specific abnormal outflow values can be set for each pump. Pump phase 1 and pump 2 phase 1 are for alarms related to current drawn by the pump. This is the one that we'll be selecting at the end. Rain, it's to warn of a rain event. Temperature is to warn that the temperature of the device, and therefore probably where it is located, is now at a temperature that is abnormally high or low. Total outflow is for all pumps in operation. So let's go back to pump 1 phase 1. We'll reproduce this setting for pump 2 after. So let's use a name that is more meaningful when receiving an email. I want to specify high current P1, and I want this to be above 10 amps and for a minimum time of 5 seconds. The final delay represents the minimum time with a normal measurement necessary to be considered this alarm has ended. The mute delay is the necessary waiting period before being able to regenerate this alarm again. In the options, active allows you to deactivate or not the displayed or created alarm. Display alert is to display the alarm on the device's screen. It's like a pop-up that you have to click to return to normal screen. Critical is to indicate the importance of the alarm. If critical is not checked, then the alarm is considered a warning. Read analog input faster is for battery operation only. For example, if we want to take faster reading when the digital input is active, we had an alarm with the condition must acknowledge to stop alarm is to indicate that someone should recognize it on Maid Maps. When must acknowledge is not checked, when the alarm ends, it will go to the normal alarm log instead of the current alarm log, but will still be part of the monthly report. The Maid Map section is to notify of the alarm by email or text message when sent to Maid Map is checked. Notify user as start will send a message when the alarm begins, which means when the condition is true for at least the initial delay entered. Notify user at end will send a message indicating the end of the alarm. The relays that can be checked relate to the selection made in the input-output dialog. A relay can be used to turn on a light outside a panel to indicate an alarm condition, or to turn on different indicator lights depending on the type or importance of the alarm, or to indicate to a PLC via its digital inputs an alarm state. Check the relay to be used for this alarm. Here is another example of a warning when a pump is blocked. Set the alarm type to value in abnormal range. Then the event type has to be related to pump 1 phase 1 for current. Then enter the abnormal range, let's say between 2 and 7 amps. Give it a name that is meaningful and set a minimum delay before generating the alarm. Then press OK and the alarm is created. If I want to duplicate an alarm, I would go here, duplicate. Here I have a copy, and I would simply specify that's the one. I would change the name and say OK. That's how easy it was to do that. Of course, modify and delete are self-explanatory. Press next. The communication setup screen. This video will not explain how to use a fixed IP address, since this is rarely required with Maid Maps. The Maid Map server address should not be changed. The important parameters in this window are the number of times data is sent to Maid Maps and for the transfer of data file. Send Maid Maps data is to indicate how often the map, graphics, and data displayed on Maid Maps are updated. The amount of data downloaded and displayed will be almost the same whether it's every 5 minutes or every hour, but the screen refresh time will be different. We recommend sending data every 5 minutes. Alarms are sent as soon as they occur. Bandwidth might be affected if real time is selected. Every 5 minutes is the suggested frequency. Send data file is for monthly reports, which are completed at the beginning of the next day, as well as for overflow reports and for soft-made data file. It's rarely necessary to download these files more than once a day. So once a day is the frequency normally selected. The send data after important change was related to alarms, but is not used anymore. Press next. The report option dialog is only if you want to report overflows. When reporting overflows, either through the digital input or the level sensor, the minimum overflow time required to be considered an event to be included in the report can be specified. The period duration is set to ignore overflow even shorter than, and the default is 5 minutes. Many use only 1 minute. Entering 0 means as soon as the event occurs, it is recorded regardless of its duration. This only applies to overflows and not to pump cycle, which are normal events. Press next. So it's now time to save the configuration file. So in the save folder directory, local copy is where the configuration file will be saved on the computer. The location can be changed. If the directory and its paths do not exist, they will be created. By default, the configuration will be saved in your document directory, under Maid Labs, and under device configuration. Since the initial configuration needs to be copied from a USB stick to the device, it is possible to copy the configuration file directly to the USB stick by checking Copy to USB key. If none are in the list, insert one, press refresh, and now you have one. Press next. The first configuration must always be loaded into the instrument from a USB key. Then some parameters can be changed directly in the device. For instruments with internet communication, such as with cellular modem or Wi-Fi, it is possible to modify the configuration remotely. To send a configuration through the Maid Maps server, click on Send to Maid Maps. When you press on Change, you can enter your username and password, and press Remember Password if you don't want to enter these all the time, and press OK. And the configuration will be uploaded to the server, and the next time the instrument talks to the server, the new configuration will be uploaded. This is not the only way to download the configuration through Maid Map. And this concludes the description of the configurator for the Volucalc CS. Thank you.